is who I teach, the youngest members of our school community. I'm an early childhood educator, working to lay the foundation for our youngest learners. But then I became a technology integrator. And although I work in this fast-paced, ever-changing realm, with each new innovation, my job is to figure out what learning lies at the very core of it and break it down so even a 4-year-old can understand it. So, when I was suddenly in a position where I had to teach coding and robotics to 4- and 5-year-olds, I put on my early childhood hat and set out on a mission to make it not only accessible to the students, but also to the teachers. Our school's engineering and robotics standards state that students from pre-K to 2 should learn to 1. Understand that computers and robots act based on what we tell them to. 2. Understand that a computer program is a sequence of instructions that are acted out in order. Each instruction has a specific meaning and the order of the instructions affect the result. 3. Use computer programming language with a visual programming language or VPL to instruct a computer or robot to complete a simple set of tasks that involves a short series of commands such as forwards, backwards, turn, and go. 4. Create a program in a given number of moves or in as few moves as possible. And 5. Predict the output of a small set of basic program commands. For our final project in COETAIL, we were tasked to implement our learning with our students. I chose 3 of my favorite ideas: global collaboration, digital citizenship, and visual literacy. Then I took them all and combined them with coding and robotics. This is one area that I teach all year long and is becoming increasingly relevant in today's world. With everything that was just discussed, I hope to find ways that teachers could integrate coding into core curricular areas such as literacy or math. The big question was how. My overall goal, however, was to redefine what coding looked like so that it would have an authentic place in the early childhood classroom and resonate more with the teachers in this field. To me, this actually meant unplugging, so that even a teacher without a device could still teach their students how to code. Alright, it kind of sounds like I'm moving in the complete opposite direction of what we're supposed to be doing, namely integrating technology, not removing it. But hear me out, and let's begin. Step 1. Gather collaborators. I sent out a tweet and kept my fingers crossed. Luckily, 3 people replied and were willing to join in the fun. Step 2. Plan the process. I divided the project into 3 parts: a literacy focus, a math focus, and the last part would be open-ended to allow for student creation. Since I was aiming to create an unplugged experience, I used the idea that a student could be the robot and would move through a maze of papers laid into a grid on the floor. Step 3. Execute the plan. Part 1. Literacy, specifically phonics and retail. The kindergarten classes practiced differentiating CVC words with middle short A and E sounds, while the first grade classes focused on matching CVC words to their CVCE partners. For this part, students coded with arm positions. I used the motions from Code.org's Move It game and adjusted the vocabulary for my project's purposes. I began by brainstorming a list with my students of words that had the middle short A and E sounds. I asked the students to think carefully about which of these words they could easily illustrate, engaging them into their visual literacy skills, and we chose 4 words from each list. Then I sent them off to draw. Once we had all the drawings, the students decided they wanted to challenge the other classes to walk over all the words with the middle short E sound. So they had to work out how to arrange the papers into a grid that allowed the robot to pass through all the words with the short E, but without stepping on any short A words. At the same time, not make it too easy. We tweeted out our challenge maze and sent along a Google presentation with the images for the maze so that they could easily be printed out. The Google presentation also helped teachers and classes figure out what the pictures were, just in case they weren't that obvious. I mean, we're working with 5-year-olds after all. Here is an example of a maze we received from the Phoenix School, challenging us to find our way around all the words with middle short E sounds. The students programmed a classmate through the maze using arm movements. Then they all got in a line so that we could show the full program and tweet it back to our challengers. Here is an example of a maze by St. Raymond's School in Illinois, where you have to match CBC words to their CBCE counterparts. And finally, a maze by the American Embassy School in New Delhi, with a focus on retelling the story of the very hungry caterpillar. The students at St. Raymond solved this challenge. Here is their program. Part 2 was all about math and adding up to 10. This time there was an added challenge. We had to make sure to jump over black holes, and that meant using the jump command in the program. So instead of using arm movements, we were now programming with the use of arrows. I began this part by giving students 10 counters each and asking them to split them up into 2 groups. We then split these groups in half again to make 4 groups. I recorded what combinations we came up with and voted on 2. Once again, the students were sent off to create the numbers for our maze and the black holes. This time we had to work out how to put the numbers into a combination which would allow the robot to add up to 10. One of my favorite things that happened was a student at AES in New Delhi came up with a solution that I totally did not expect. Instead of moving around the maze, this student decided to just step forward and backward between 2 number 1s until he had added up to 10. I just loved how this simple game gave students the opportunity to think out of the box and get creative. Here is a challenge we received from St. Raymond's School. We worked out 3 ways to add up to 10 and wrote the program for each of them. We decided that blue was the best way because it was the shortest program. Part 3 was the final challenge. It involved the students using the concepts they had learned to create their own unplugged coding game. First, the students had to create the code. The rules were that they could not use any of the symbols from our previous games, so no arrows and no arm movements. Coming up with the symbols for these commands was truly an exercise in visual literacy for the students. I explained that these symbols had to be very simple to draw because when we are using these symbols to write a program, it needed to be easy enough for others to recreate quickly. For this reason, I only allowed students to draw with a pencil and go over their lines with black marker.
This is rocket going forward, backward. This is a rocket that is going backward. This is a snake. Turn right. Turn left. This is turning left. The laser shoots, makes rocket to a sand. This is the angel. The angel moves 3 times.
We then had to create the rules. In this game, the robot must collect all the stars and finish at the treasure chest. Be sure to shoot the lasers at the rocks before you move or you won't be able to pass. The angel is a special code that helps you to do any move 3 times. Roads were normal squares that you could pass through. We played the game and came up with one solution as an example for our collaborating classes. Here is one solution that our friends in Illinois sent. We read their program and found a bug, so we decided to debug it together. Composing a tweet to send back to our collaborators helped the students practice digital citizenship. We had to be respectful when letting them know that we found some bugs as well as show kindness and compliment them on their work. The Phoenix School also sent us a program. In their video we saw there was a bug, but when they sent us their program we saw they had already debugged it. Once again we sent back a tweet, practicing kindness and respect when composing it. The students at AES also sent a program. Here is their solution. They've told us that they've started planning their own game. We're very excited to play it. Here is a game created by the students at St. Raymond. In this game, you must collect your bag and then go get all the coins, jewels, and the key before finishing at the treasure chest. If you step on the bat, you get to take 1 extra step forward. If you land on the super person, you get to take 2 extra steps forward. This game is from the Phoenix School, and it's all about cleaning up a coral reef. The rules are that you must pick up all the trash before you finish at the clean coral reef. Avoid the sharks, or you have to take 2 steps back. Finally, you must step on every space except for the sharks before finishing the game. We can't wait to start figuring out the program for your games. Step 4, reflect.
Figure out how to figure out the test. Like being a robot, and I like find a program. In choice time, we made our own code again. We made booby traps. I can make my own code like the laser.
So, what about me? Did I reach redefinition? If we're going by the SAMR model, sure, in some ways I did. Through the use of Twitter and Google presentations, 4 classes in different parts of the globe were able to collaborate. But I'd like to think that I redefined redefinition a little and turned it on its head. Even though this collaboration never would have happened without technology, my main objective actually was to take a unit in technology and integrate it into the curriculum. Perhaps I didn't quite redefine a unit in the traditional SAMR sense, but I feel like I did redefine what coding and robotics can possibly look like when integrated into the early childhood core curriculum. Through this experience, we found out what worked and what didn't. Hopefully, we'll be able to take these reflections and turn the project into a global unplugged coding exchange. Once I come up with a snazzy new hashtag, I plan to collaborate with one of the Global Classroom's co-founders, Michael, to build this into a project where classes around the world can find and contribute to a collection of unplugged coding challenges, creating a growing bank of games that teachers can use in their classrooms. And I'm keeping my fingers crossed.